Good afternoon, my name is Hunter Manning and this is my submission for Lab 6, Magnetic Molasses. The purpose of this lab was to observe real-life and simulated models of a bar magnet falling through a conductive tube of aluminum foil. To do this lab, multiple key concepts were used. The Biot-Savart law calculates the magnetic field when given a charge, velocity, and distance, as seen in the equation below. Further, magnetic flux is the component of a magnetic field that passes through a surface. Faraday's law was also used to find the EMF that is created by the negative derivation of the magnetic flux with respect to time. Finally, Ohm's law was used to relate current and resistance to the EMF found using Faraday's law, as I just mentioned. And to the right, you can see the equations for these concepts. This experiment involved two objects, a bar magnet and a conductive pipe. The tube was 46 centimeters in length and had an inner radius of 1.5 centimeters. In this lab, we dropped the bar magnet down the tube vertically 5 times and averaged the time it took for the bar magnet to come out of the bottom end of the tube. The average falling time was around 1.396 seconds. Moving on to the computational model, I manipulated the GlowScript starter code that was provided to us to produce a model that represents what we did in lab. I first inputted the lengths and widths of the pipe. I then inputted the relevant masses and magnetic dipole values. Further, I added the relevant position, magnitude, and unit vectors for the magnetic dipole. Continuing with this GlowScript analysis, above you can see the code for finding magnetic flux, which is important in finding the EMF via Faraday's law. I then inputted the relevant values and equations for magnetic force and found the net force by adding magnetic force with the force of gravity. I finally inputted the equations for the magnetic field of the ring and the relevant angles and magnitudes needed to find this value. Moving on to the discussion, by observing the simulation, which you can see on the right, we can gather lots of data of the falling magnet experiment. The first question was, which color responds to the clockwise current when viewed from above? The red color represents the clockwise current, while the blue color represents the counterclockwise current. We found this by using Faraday's law by recognizing the flux on the ring points up and decreases in the areas above the magnet. If we flip the magnet, the red currents for each color would be flipped. Red would be counterclockwise and blue would be clockwise. Now, how does the real world experiment that we did in person look when compared to the computational model? The real world model stayed in the tube about twice as long as the computational model. This suggests that there could have been some error in the experiment. Perhaps my timing of the magnet falling was playing a role in this, or we could have had an incorrect calculation of the magnetic dipole moment, which was inputted into GlowScript. The final question is, how does the velocity versus time chart look? The shape of the velocity versus time graph tells us that the velocity decreases over time, and this allows us to infer that gravity could be stronger than the magnetic force on the magnet. Moving on to the assigned what-if questions. The first one was, what if the resistivity of the conductor were reduced as close as possible to zero, and how would this change the dynamics of the falling magnet? Using Ohm's law, if the resistivity of the conductor decreased, the current would have to increase to create the same voltage. This change would be significantly effective in increasing the magnetic force on the bar magnet, which is denoted in the cross product of the current times the change in length with the magnetic field. Moving on to the second what-if question, what if we cut holes or slots into the tube? How would this affect the ring currents in our model? Cutting holes would impact the induced ring currents that produce the magnetic force in the system. The overall magnetic force would likely decrease as a result of cutting holes or slots into the tube. Thank you so much. Have a nice day.